Good morning, everybody. Happy afternoon, and thanks for calling in to Seals in the Afternoon. Today, our topic is a phrase called explosion proof. And if you've dealt with supply systems, motors, instrumentation, things like that, you've run into the phrase explosion proof, and you'll see it on a lot of our supply system drawings. Let's go through what this means and what it does not mean. Explosion proof is a term used to describe a characteristic of an electrical housing or enclosure of components like transmitters, switches, and motors. Now, to meet the criteria for the explosion proof rating, the enclosure must be able to contain any explosion originating within its housing and prevent sparks from within its housing from igniting vapors, gases, dust, or fibers in the air surrounding it. So when we say explosion proof, we are referring to enclosures, whatever that might mean. It could be an enclosure on a transmitter, an enclosure on an electric motor, on the junction box of an electric motor, and then a whole bunch of other stuff that you'll run into out in the field. So when we say explosion proof, it does not mean that it is able to withstand an exterior explosion, or more importantly, does not mean that it can prevent an explosion from occurring. All right. Instead, when we say explosion proof, we're talking about the enclosure's ability to prevent an internal spark or explosion from within the enclosure from causing a much larger blast. So let's talk about enclosures a little bit. One of the most important factors of an enclosure is, of course, the thickness of the walls. And the enclosure must be carefully designed to ensure also that the heat transfer from within the enclosure, in the event of an internal explosion, will not raise the temperature of the outer surface of the housing to a level where the combustible fuel or mixture surrounding the pressure transmitter or motor can be ignited. So it has to do two things. Number one, it has to physically and mechanically contain the expansion of gases from within inside the enclosure, and then it also has to limit the surface temperature to the point where it won't cause auto ignition of something outside the enclosure. So let's talk about electric motors. Now, for an electric motor to be explosion proof, it has to be made so that it will contain an internal explosion without rupturing. Now, that means any hot gas is escaping the enclosure, and I'm talking the body of the motor itself, are forced to exit through long, narrow openings called flame paths. You probably didn't know that a flame path was in there. And so as these hot gases from the explosion travel along these paths, they have to be cooled to a temperature low enough, of course, to prevent a further explosion in the area surrounding the motor. And the same applies for the terminal housing, because of course there are electrical contacts inside the terminal housing, and that has to be bolted closed per the exact manufacturer's recommendation. So if you walk up to an electric motor and the terminal housing is not bolted down, or it's missing some screws or what have you, it is no longer explosion proof. One second, I gotta take care of something. Okay, so it's no longer explosion proof, no matter what the nameplate says. Okay, if you have a motor that's completely shrouded with stuff, there's a t-shirt hanging over it, or a big piece of insulation is hanging on it, or it's in a very tight space, it might not be explosion proof if it can't get that flame path cooled down and out of the body of the motor. Okay, now let's look at transmitters. which is even more important because that's something that we supply. Now, again, for a transmitter or even a switch to be explosion proof, again, it has to contain any sparks or internal explosions, not prevent them from occurring. And so, again, this means the explosion proof protection will be lost if the housing is not properly bolted together or screwed down per the exact recommendations of the manufacturer. Now, a lot of times for for switches and things like that, it's even just screwed down with just some Phillips head screws, and you got to make sure that those are tight. If there's any sort of internal seal or gasket that helps seal off that housing, you got to make sure that that is there. So if you're going to take apart or open an enclosure, for example, to wire it or connect it, as soon as you loosen one of those screws, you have lost the explosion-proof rating of the enclosure. And so that's why if it's not locked out and tagged out from the energy source, you can be in big danger, and you can put a lot of other people in danger too. Now with transmitters, and this is pretty much true with all the manufacturers, whether it's Emerson Rosemount, Indershauser, Yokogawa, some other ones, the actual face of the enclosure screws off, and it's usually about I'm guessing maybe a 3, maybe a 4-inch thread, and it takes a number of turns to get it tightened down. And so if that's not tightened down per the user manual, again, you have lost your explosion protection. Now, one more thing about explosion protection, it does not mean that no gases can get in and no gases can get out, okay? That is different. That's called intrinsically safe. You can also have some enclosures that are even purged with nitrogen. They get pretty fancy. What we do with explosion proof is actually pretty much the lowest level of protection that meets explosion proof. And that just means something inside it can go bang and it's not going to hurt anybody else. And so there are basically kind of 3 general explosion proof specifications that we usually have to meet with our components. The first one is called NEMA 7. NEMA stands for National Electrical Manufacturers Association, and that controls, that was originally started for motors, but it also has expanded to enclosures. And there are 2 NEMA certifications. One is 7, NEMA 7, and that's for vapors, and NEMA 9, which is for dusts. You'll also hear NEMA 7 referred to as Class 1 Div 1, and you'll hear NEMA 9 referred to as Class 2 Div 2. So Class 1 is vapors, Class 2 is dusts. And of course, we deal mostly with vapors. So you'll see a lot of NEMA 7, Class 1 Div 1. We don't do a lot with dust atmospheres. That's a lot of stuff like, motors on blowers and, grain, and some other things that are dust processes. The third specification comes from ATEX. And remember, ATEX is a European organization. And because it's European, almost all of the terminology originates in French. And that traces its roots in the ISO organization, where a lot of things were in French. And so ATEX is actually shortened from Atmosphère Explosive, which is French for explosion proof. And we often see a marking called EXD, as in David. So it's EX space D. And actually that E is an epsilon, but don't worry about that. And so the EX-D is what they call flame proof. Flame proof is synonymous with explosion proof. They are not 2 different things. And if you remember, with motors specifically, I talked about a flame path, where if something were to ignite inside the enclosure, that flame has to travel a certain path, and the enclosure is designed such that it will cool off that flame, so that the only thing that exits the enclosure are the products of combustion, which is usually carbon dioxide, carbon monoxide, and water vapor. So that's why the EXD is called flame proof. And flame proof, the D comes from the D in deflagrant, which is it's actually the abbreviation is for anti-deflagrant, which is French for basically anti-flame. So again, anti-deflagrant is flame proof. So that's not an easy way to remember what the D is, but that's what the D is. And the ATEX EXD is real similar to the requirements of NEMA 7. And that means same thing, the way the enclosure is bolted down to mechanically withstand the stresses from the explosion. And then number two, it has to be designed with a certain material thickness and volume and flame paths so that the external surface temperature of the enclosure is low enough that it won't auto-ignite combustible vapors that surround it. It's not meant to keep anything out other than rain, of course, and wash down, but it's not designed to keep vapors out of it. It's not designed to completely keep vapors in it. It's designed to contain the explosion and prevent an auto-ignition explosion or even flame-induced explosion outside of the enclosure. Okay, thanks everybody for calling in. Have a good day. Talk to you tomorrow.